HET 273, Pneumatic, Electric, and DDC Automation. Week 3, Control Principles. This week's assignments will support the HVAC Learner 2. Understand the functions of controls, understand sensors, understand controllers, understand controlled devices, understand control agents, describe control system characteristics, distinguish between open and closed loop systems. The understanding of control principles are critical for the technician to properly troubleshoot and operate HVACR systems. Specifically, the understanding of each type of control and how they work together to operate systems in a safe and economical manner. This knowledge will help the technician as problems can arise at any point in the system. This week's vocabulary: offset, proportional band, feedback, closed loop, controlled device, control agents, controller, sensor, set point, proportional control. Control components. Sensors. We have temperature sensors, humidity sensors, flow sensors, and pressure sensors. As you can see in the picture here, this is an older style sensor that we used to use. Sensors are very important in the feedback aspect of our controlled loops and are located in the streams that are being maintained, whether it's airstream, liquid, or air pressure. Sensors are critical and calibration is of utmost importance. Controllers. Controllers receive a signal from a sensor, use a program or settings to create an output. They send a signal to the control device. In this slide we see two different types of controllers. The one to the upper right is a pneumatic VAV controller. We have several inputs coming into it and an output going out to control a VAV box. It can work in several different ways. This one can be for a normally open, normally closed box. It's several different, or any actual spring range that can be calibrated to work the VAV damper. The one below is a DX9100 Johnson Controls component working with Metasys. In this one we put in a program. As inputs come in, it reads those inputs, makes whatever changes need to be made, and sends an output signal to the control device. Control devices. We have valves and dampers. And there's other sorts of devices. But here we'll stick with the valves and dampers as they're the basics. The upper picture is a VAV damper. This is actually what's inside of a VAV box that you would see out in any commercial building. The back part of it with the little stem sticking out is the air damper, which moves that long piece where you see where the spring is forward and back to operate and maintain an air pressure in the system. The lower picture is a valve, the large actuator and a pilot positioner on it used to control the flow of a liquid. Control agents: air, water, steam. In our last two slides we saw components that controlled air, the VAV damper, and water, the valve. Steam can be controlled in the same manner. Control point. Control point is the actual sensed temperature, humidity, or pressure in the space, pipe, or area that we're trying to control. And the control point is sensed with a thermometer, thermostat, humidistat, or pressure control. Set point, the temperature, humidity, pressure point that is to be maintained. An example would be a thermostat trying to maintain 72 degrees. The 72 degrees would be the set point. Offset, the difference between set point and control point. An example would be that same thermostat trying to control 72 degrees, but our space is 74 degrees, leaving a 2-degree difference between the two. So in essence, our set point 72 degrees, control point 74 degrees, offset 2 degrees. In this case, our thermostat will try to work using the system to bring the temperature as close as it can to the set point. Feedback. This is the measurement of a controller's actions. In the previous slides, the feedback we got from the sensor is fed to the control device, which reacts on the controlled agent to control our temperature, humidity, or pressure. Feedback is critical for the operation of a closed-loop system. Closed loop is the arrangement of a controller, sensor, and control device in the system. Closed-loop control happens when there is feedback occurs between the controller, sensor, and control device. Using the examples I have been, we have a thermostat in the room set at 72 degrees. Our control point is 74 degrees. We have a 2-degree offset. We would bring on the cool air from the damper to try to bring our temperature down to the 72. So the controller would work upon the damper to bring that temperature down. Open loop. There is no feedback and is usually used in reset controls. That means if we have an outside air temperature sensor with a boiler system, we could bring the boiler system on at 60 degrees and we could have a reset schedule going down to, say, 30 degrees. We could have a boiler water temperature starting at 160 going to 200. As the temperature outside were to drop, it would feed back, allowing the boiler to increase its temperature from the 160 to 200. So the reset would be 60 degrees on high end outside, 30 degrees low end outside, bringing over a 160 degree low end boiler water temperature, and then at 30 degrees we would have the high end water temperature of 200 degrees. That is a basic open loop reset control scheme. Control loops, on-off control. Turn system on and off to maintain a set point, has a large offset. That means is we're on, we're off, we're on, we're off. It's kind of like your home thermostat. That system, it does is just brings the system up, it runs up to temperature, shuts off, waits a period of time till the area cools off, turns back on, brings it up to temperature again. Control loops, proportional control, analog. Control in which the control device is positioned in direct response to the amount of offset in the system. It is used in both open and closed loop systems. It uses a response that is a number between two values. 4 to 20 milliamps, 0 to 10 volts DC, or 3 to 13 psi. Analog is any number between a point. In summary, on-off is when the controller produces 0 or 100%. Closed loop is a control where feedback occurs between controller, sensor, and control device. The arrangement of a sensor, controller, and control device to maintain a specific controlled variable describes a controlled system. The HVACR technician must understand the control system relationship in order to troubleshoot systems. Control system components work to maintain building comfort. The sensor measures a variable and reports to a controller. A controller receives the measurement and sends a signal to a control device. The control device regulates the flow to provide the proper cooling, heating, and ventilation.